Okay, ji, this is complex number lecture number 8. So let's just work upon it. If we say that we have, or let's work upon locus of a complex number. So locus of the complex number. So we need to understand something. If it says equidistant from a point, equidistant from a point. So what does equidistance from a point mean? It means draw a circle around that point. Draw the circle around that point. Example, 2 centimeter away from a point. So what does 2 centimeter away from the point mean? For suppose if this is your center, so your 2 centimeter away from the point will be, if this is 2 centimeter, so it will be 2 centimeter on the left hand side as well. So we can always draw a circle that is representing 2 centimeter from the point. Now remember that it will be the radius. It will be the radius of the circle. So this is the representation this of the circle. But if I say that how will it be represented in the complex number normally, the representation of this is that we can always write this in the form of modulus z minus a plus iota b is equal to r. Now, your a plus iota will represent the center point. So this will represent the possible position of z r at a distance from r units from a plus iota b. Now let's just say that we have modulus of z is equal to 3. Now if the modulus of z is equal to 3 is given, that means z minus o plus o iota, which means when it's only the z, that means we are talking about the origin. We are talking about the origin, and this should be equal to 3. Now if we just work upon the axis, let's say this is your x and the y axis, we can have 3 minus 3, let's say 3 iota and minus 3 iota. So the origin is the center, and the circle with the distance of 3 will be drawn that will cut all the points with the same distance. That means from each of the point here, you need to understand that each point will have the distance of 3 to the top, right, down, and towards left. All the values will have distance of 3. So this will be for what? The argand of normal circle with what? Z, modulus of Z is equal to what? 3. If I say that we have Z minus 1 minus 2 iota modulus close is equal to what? 2. Now, if I just draw this, that means we are drawing it in such a way that we have 1, 2, 3, 4, minus iota, minus 2 iota, minus 3 iota, minus 4 iota. And let's say we have minus 1 here. So the value that we need to understand is that this thing 1 minus 2 iota will be 1 minus 2 iota at this point. This will be the value 1 minus 2 iota, right? So if this is 1 minus 2 iota, so at this particular point is the point of what? Complex. This will be the distance, the radius. So from this point, 2 points will be on the right hand side, 2 point on the left hand side, 2 point to the top, 2 point to the down from the center. So if we just draw the points, that means this will be your point, the center argand, 1 minus 2 iota. And if we just want to draw the circle, you can always have the compass with you. Your compass will be necessary with 2 centimeter from the center. So this will become what? Your circle from the distance of 2 centimeter distance in all the sides. If you just note 2 centimeter, 2 centimeter. So if we just look at this represents the distance of 2. This represents the center of the circle. Let's move ahead with another example. If we say that z minus 2 plus iota modulus less than equal to what? 1. Now, what does it represent? This minus 2 plus. Now, the form that we actually knew was, the form was z minus a plus iota b modulus close is equal to r. So that means we need to shift this into the form negative. So this will be 2 negative I modulus close less than equal to what? 1. Now this equal to less than equal to means that the circle that you are drawing will be the dark line. It will not be a dotted circle. It will be a dark circle. If the less than equal to sign is not there, if the equal to sign is not there, for suppose this less than sign is there only. So that means it will be a dotted circle. But if it is an equal to, so that means it will be a dark line circle. So let's just move ahead with the same concept. We know one thing here, and that is that the complex number is 2 minus iota. So solving this will be that the center is 2 minus iota. That means 2 in the fourth quadrant. So if we just draw the line stating this is the real value of z, this is your imaginary value of z. Let's say 1, 2, 3. Then we have is minus iota, minus 2 iota, minus 3 iota. So the center of the circle is 2 minus iota. This becomes the center. But now you know that the radius here is 1. So if we just plot it down here, let's say this, 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 and this. So this will give me a circle with all the points. This will give me a circle with all the points. And the distance will be what? Distance will be 1. 1 on the right hand side, 1 on the left hand side, 1 up, 1 down. Now, what does this inequality represents? Normally, you had equal to sign. If you had equal to sign, then it was fine. But your inequality represents that it is shading part. It is shaded. And where do you need to shade? You will be shading it inside the circle. This will be shaded and this will be shaded inside the circle. Then what do we have in this? In the complex number, we have the equidistant between 2 points. Now, what does equidistance between the 2 points mean? A perpendicular line. Perpendicular line, and that perpendicular line is basically your perpendicular bisector. That perpendicular line is perpendicular bisector. So if you need to find out the perpendicular bisector or draw the perpendicular bisector, so what do you need to do? You need to understand that the 2 points, if this is A and this is B, so you take the compass, put down on the A. When you put down on the A, you will draw the line. You put down compass here, draw the line. This line will be here and here. Compass, your line is here and here. Similarly, if the compass line is here and here, then you'll keep the compass here, draw the line here and here. So the line will be your perpendicular bisector line, creating an equidistant line. So if we just create an equidistant line, so putting down on the A, your equidistant will be here. Putting down on the B, your equidistant will be here. So that means when you are drawing the line, your line will be cutting what? A and B from the middle. So this will be your perpendicular bisector. Perpendicular bisector. Now, since you have the perpendicular bisector line, so the question can revolve around perpendicular bisector as well. So that means the representation of in complex number. Representation in complex number of 2 points. Complex number. So whenever you have z minus a1 plus iota b1, this should be what equal to, or the inequality will be there, z minus a2 plus iota b2. So this will be the 2 points stating that both the lengths are equal when they are bisected. Now, if we just say, let's say, take an example. If we just say that z modulus is z minus 3. So what does this mean? This means that this is z minus 0 plus iota b, or 0 minus, which is what? 0 iota is equal to z minus 3. Now this is your real number. Obviously your 3 will be there, but negative is here, right? So we write down 3 plus 0 iota. We write down 0 iota. So these two values will be there, noting that if we just draw these 2 points on the axis, let's just draw these 2 points on the axis. This is your real value of z. This will be your imaginary value of z. Noting that z 0 0. So 1 point is 0 0. Let's just write down 1, 2, 3. So 1 point is 0 0. And the other point is what? 3 and 0. So 1 point is 0 0. The other point is what? 3 and 0. So perpendicular bisector of the line. This is your perpendicular bisector line meeting the 2 points. So if the line will be drawn in such a way that it will create a perpendicular bisector, stating that both are equal. So this will be your perpendicular bisector line, and this will be at what, 1.5. This will be at 1.5. Okay, now let's just continue with another example. Let's say that z minus 3 iota is equal to z minus 3. So let's just say that z minus 0 plus 3 iota modulus should be equal to what, z minus 3 plus 0 iota. Now let's just draw the axis. If we just draw the axis, this is real value of z. This will give me the imaginary value of z. Iota, 2 iota, 3 iota. And we have 1, 2, 3, and 4. So now 1 point is 3 plus iota. So this will be 3 plus iota, and this will be 0. So this is your normal line. This is your normal line. So if I want to take the perpendicular bisector or draw the perpendicular bisector, I'll draw it through what? Put the compass here. I'll draw the axis here, this x, and then obviously draw an arc. And when the line will intersect these two arcs, it will create a perpendicular. It will create a perpendicular bisector. So whenever the equal to sign is there, you will just need to create an what, perpendicular bisector, nothing more, nothing less. But if we have, let's say, inequality now, z minus 2 plus 3 iota, if we have less than equal to z plus 1 minus 2 iota. Now, what does this mean? Z minus 2 minus 3 iota modulus less than equal to z plus 1 minus 2 iota. So this is your normal form. So if I just want to point out the lines or point out the axis, so let's just draw the axis first. So this will become your axis, right? Let's say this is your axis. This shows the real value of z. This shows the imaginary value of z. Iota, 2 iota, 3 iota. Here we have negative iota, negative 2 iota. 1, 2, 3. Minus 1, minus 2, minus 3. So 1 point here is 2 and negative 3. 2 and negative 3 will be here. Noting negative 3 and 2 minus negative 3 and 1 minus negative 2. So we have 1 minus negative 2. Just a bit of, let's just work out with this. We need to have negative here. So if I create a negative here, so the signs will change so that we will have the impact. So if we change this to negative, so we will have negative 1 and positive 2 iota because of the general form of negative, that is z minus a plus iota b. Now the second point will be minus 1 and 2 iota. So this will be your second point. So if we just draw the line, so this will be your line of meeting 2 points. This will be your line of meeting 2 points. So if we just draw the line, this will be the line meeting 2 points. And now we need to create the perpendicular bisector. So just marking the x here and the x on the other side. So this will create your perpendicular bisector line. Now, but there was one inequality. So when there was one inequality, we need to always consider if this is less than. So obviously less than means that whenever the less than is there, it will always create what? Acute angle, remember. So that means this side will be shaded. So the entire, this side will be shaded. So we will shade this side of the complex number. So it can be equal to, or it can be quotient that will be based upon the shaded region.